Thanks for coming along, everybody. I am doing a talk on Terraform that I like to keep a really long name on called Terraformally invite you to start using Terraform as the infrastructure as code tool. It's a name way too long, but I originally did this talk similar to this at DDD Adelaide, and it was too long and they asked me to change it because it didn't fit on the cards, and then they ended up just sticking with it, and it's funny ever since, so that's the name. But beyond that, I'm Ryan. I'm a senior consultant at Arcana. I do lots of migrations and deployments of apps from on-prem, other cloud platforms, or even Azure itself to modernize what they have and put it on the Azure platform. And I do that all day, every day using Terraform. Beyond that, I'm a network infrastructure guy with background with on-prem hypervisors, all that sort of stuff. But part of my journey to get here is hate clicking, much prefer automation. So everything I do is with that in mind. Cool. All right, so I figure this is a bit of an entry-level conversation into what Terraform actually is and why you want to use it. So the first start is the who, what, when, where, whys. The first one is who is infrastructure as code for. So by the name, you probably can tell, it's defining your infrastructure as code. So some repeatable and can be modified and version controlled. So part of that is you get to predefine the end state as code. So rather than having to click through multiple different things and making the discovery, you get to do it all as one big bang, which helps you sort of understand further of what you're trying to do, what you're trying to define, the ins and outs, and more of those sort of hidden bugbears as you go. You get to find them up front rather than finding them later. It's repeatable, changeable, version controlled. So part of it is it's in just code. It's in text files, effectively, that get logged into your Git or whatever other version control you're doing. So you do have copies of that code. You can collaborate with other people. You can comment on it. You can tell people why this is like this way. And it's much more intuitive to read through and understand the overall intention than what the portal is or something like that, where there is just the things you're looking at, the infrastructure is there, but it doesn't tell you the context of what it's doing. Lastly, it gets to minimize the human interaction. Everything is happening through code. You're using it through CI/CD pipelines. You don't have to click through the portal. On trying to deploy two VMs, one of them has 2 CPUs, the other has 3. Happens all the time. When it's in code, you get a lot more control over how that actually deploys out, and you can spot those things earlier or make them programmatic in that they don't ever happen. Got lots of transitions. They're going to look awful on the PowerPoint slide. Cool. So with infrastructure as code, there's 2 major schools of thought. There's imperative and declarative. So these are good concepts to understand, but they're not really a functional thing in practice. But the idea is that imperative is a script-based logic, something like a PowerShell or a Chef. You've got line by line, I want to deploy a resource group, storage count, a network interface card, or a virtual network, a NIC, a VM. You do that line by line in something like PowerShell. But if something goes wrong, the NIC doesn't create, the VM won't because the script is broken. You can build in logic to make it smarter, but otherwise you have declarative, which is something like Terraform, Bicep, Pulumi. These you don't care. You go into the airport, you get into the Uber, you say, I want to get there. You don't care what streets they're taking, whatever's going on. You just go from A to B. And that way it's self-correcting. It lets you know what's going on, as well as if something is incorrect, like the VM has the wrong name or something like that, a declarative system should be able to pick that up and change the name to suit rather than the imperative, which is one and done. So this is an easy throwaway slide for the who, what, when, where, why. The when is 10 minutes ago. It's always useful to have these tools up your sleeve, and particularly with tools like Terraform, they're not all or nothing. You can bite-size them. You can start learning as you go. You can bring in old configurations. You can start new. I find this is important to mention because they always sound big and scary and all-encompassing, but the best way to learn is just by using it, and you can bite-size it out. So as part of it, there is 2 places you can do this code. You can do it in pipelines and CI/CD in something like GitHub, or you can run Terraform from your local machine. Definitely, if you're going to start learning this, I would learn the GitHub way through CI/CD and pipelines as early as you can. Running it on your local machine doesn't lead to that collaborative experience, which is some of the key to infrastructure as code, as well as it's just, you've got a lot more opportunity to make a really nice and secure platform if you're using Terraform in the pipelines. When you're doing it on your local machine, you're throwing all that away. CI/CD is really important, and it's part of why this is cool. So why Terraform itself? So there's lots of other tools, like I mentioned, like the ARM and Bicep are the big ones in the Azure world. Otherwise, there's AWS CloudFormation. Yeah, tons of other ones that fell out of my head immediately. So Terraform itself is a domain-specific language. So when you write Terraform, you're writing it in HCL, the HashiCorp configuration language. That is its own language. It has no roots in anything else, as opposed to another language like JavaScript or TypeScript or something like that. It being domain-specific language does mean that your learnings for how the language works don't carry over to something like JavaScript or other programming languages, but it gives it the opportunity to be simple. When you have the alternate to like Pulumi, which is very similar to Terraform but is JavaScript, there's a lot more complications and things to learn and understand about the platform, while Terraform is just infrastructure as text. It's as simple as YAML. You can understand it. Anybody can walk up to it, maybe not write it offhand straight away, but certainly read it and go, this makes sense. Terraform itself is declarative. So as I mentioned before, rather than doing a script where just wanting to go from A to B, it'll bring your resource groups back in line. It'll add tags where they're missing. It'll update names. It'll change SKUs, as well as if that SKU is changed in the portal and it shouldn't have, next time you run Terraform, it'll bring it back. This gives good state-based operations, and Terraform's very good at the declarative side of it. It's plan and apply based, so we'll show this later. What this means is when you're running a CI/CD pipeline, the continuous integration, continuous deployment pipeline, continuous integration in the Terraform world is the plan. It'll tell you exactly what's going to change. You have to approve it, and then before you go to the CD side of the pipelines, that's people approve it, thumbs up, merge it in, go. Terraform's built from the ground up with this in mind, so it does make for a powerful process rather than getting approvals to click something in the portal. It's all very transparent in Terraform. Terraform itself is plugin driven. So these plugins are maintained by first and third parties like Microsoft and AWS, which have their own providers, which is how you interact with cloud platforms, as well as third-party ones powered by the community and generated by them. This has the benefit of there is just a ton, and I have a slide next that shows the numbers, but it's astronomical the amount of platforms this works with, and it just works with more and more and more because as the community bring more stuff in, it just keeps going. The water wheel keeps turning. Lastly, Terraform is brand name. This is a bit of a funny one because Terraform is huge. People don't search for infrastructure as code. They search for Terraform. They don't search for Bicep or ARM. They search Terraform. That's what people know. When they come up to somebody like myself and Arcana, they're not looking for infrastructure as code. They're looking for Terraform. And there's power in that. It keeps itself going. Of course, competition is great. But if you're going to learn something, Terraform is platform agnostic and super powerful and super popular. Seems like a good place to start. So this is a screenshot from the Terraform registry, the online platform where they host all the providers and modules. So there's 4,239 providers as of Saturday, which represents 4,239 potential cloud platforms that you can interact with, and 16,000 modules, which is predefined code that you can do things with. Yes?
The next question now.
If it's pressing for now, I can answer them now. Otherwise, probably at the end might be best. Did you want?
Question came up.
Okay, sure. And this is just a little screenshot from the Google Trends. The blue line is Terraform. Everything else doesn't matter because they're nowhere near the scale of what Terraform is. Terraform is just huge. The only one that holds up a bit of a candle to it is AWS CloudFormation, but that one's platform specific to AWS. Terraform works everywhere. Just driving it home that it's big. It's in comparison to everything else in the market. Terraform is the brand name. And another cool one is as part of Microsoft and their embrace of Terraform, they've recently started doing Azure verified modules, which is their pre-packaged, they're called resource and pattern modules. So in the terminology, a resource module is something like a key vault or a virtual network or a storage account. These are resources that they have all the parameters turned on and configuration to make them line up with the cloud adoption framework, which is Microsoft's patterns for making things secure and ready to go. pattern modules combine those. So you get the virtual network module, the virtual machine network, the virtual machine module, combine those up, and that becomes a deployable set of infrastructure. Those are their pattern modules. They're larger scale than that, but that's the idea of what's going on. They're built on top of each other. This is a relatively new drive, but it shows a lot of potential to actually continue existing. And they're really hot on it. They're community-driven modules, but they have ownership by people inside of Microsoft. So even if the community stops working on them as much, people inside of Microsoft are on the hook to keep these actually going. So they're planting their flag and saying this is the way, rather than it being some sort of platform that won't exist. I have high confidence that this is the way to go. Awesome. All right, so we're going to start digging into more of Terraform itself. So the Terraform lifecycle. So is where we'll start. This is a general overview of what it looks like day to day to run Terraform. So when you're starting a Terraform project, it's very much like Git. You run an init and initialize to start up your folder. Have a look, see how this looks. So the Terraform init, you're looking to have, which one's the pointer? Cool. So for those on the camera, you're probably not going to be able to see the pointer, but I'm just pointing at the main TF saying this is just the one file you need to get started. We'll cover it later. The file names don't matter. The bit that does matter is the .tf. But otherwise, when you're doing the initialize of the Terraform, you're looking to provide the metadata inside this Terraform block. And everything in Terraform is defined in blocks. Once again, we'll cover later, but this is sort of the minimum of what you're looking at. You're looking at like a required version, what providers you're looking at, which are those community-driven or first-party-driven plugins. So this one is the Azure RM one. Where you're doing a backend, which currently is local. In the real world, you'd never do it local. The backend is the state file, which I'll talk more about in a second as well. And then the provider being Azure RM. So when we run it, I've just got a little video here showing Terraform init. It downloads the plugin that you got there, the HashiCorp Azure RM one, slaps that stuff in the .terraform folder and the .terraform.lock.htl, which keeps track of what versions you've got on the project. The .terraform.lock.htl gets committed to your Git. The .terraform doesn't. That file is fully disposable, and if you are troubleshooting things, that's a good one just to delete and move on. Nothing of worth is ever kept in there. So once you're initialized, we're going to skip ahead and pretend that we've got some code ready to go. After that, you're looking at the plan. So in the CI/CD side of the pipeline, this is the CI side. When the pipeline runs, it'll do a plan. Unfortunately, this video is a touch long, but it goes through, it checks Azure, the state file, and the code files you've got themselves. So the state file is the last known configuration of what you've deployed. So if something has changed in the Azure portal, but it's the same in the state file, same in your local code, it'll change the Azure portal to suit. If something's changed in your code, but it's different in the state file, different in Azure, it'll change the state file in Azure to suit. And it uses that for its logic to make sure that it knows what's changed, what's been deleted, what hasn't, which is a key benefit it has over something like Bicep or ARM templates. You can actually delete things and not have to explicitly specify that. And it's very controllable and it tells you exactly what it's going to do. So we got here, this is the printout that goes to your logs. It tells you exactly what it's going to create, exactly what it's going to destroy. So in this instance, we're creating a new resource group. We're destroying an old one because it had a bad name. And key and an important thing to note as well is it gives you this count here of what's adding, what's changing, what's destroying. When you start working in really big Terraform projects, there could be hundreds of resources that you're deploying. It's always really key just to scroll down and have a look at this list. If it's changing 100 things and deleting 1,000, something's probably gone wrong. I'd always expect that you'd have some understanding of what that number is, and that's a very short-handed, quick way to understand what that is, because these blocks, although very, very useful, it's just a lot of information to pass. So definitely get in the habit of looking at that last little line to know. But yeah, so after the plan, we go to the CD side, the continuous deploy side, which is the Terraform apply. So this one's pretty simple and familiar once again. When it does the apply, it actually does another plan. So this is this last pre-flight check to go. All right, the plan we could have done 2 days ago, but apply we're doing right now. We'll do one last check. Video goes slow, but it will tell us what it's going to change, and then you have to say yes or no. So in your pipeline, you'd set it to always say yes because you're doing CI/CD and you can assume that deploy means deploy. But when you're on your local machine, this is what it looks like. It looks the exact same as a plan, just waiting for a yes. And also in this example, I've done the naughty immediately, and I've got a .terraform state file here. So this is where it's keeping track of the last known deploy. You'd never really have this on your local machine. It's purely just because I was doing a simple little demo. But yeah, we get to go through, it tells us what it's doing, the time it takes to complete, which is handy to know. So when you want to reproduce it. And then, yes, so that's the other resource group I had there. It's destroying that one, creating a new one. And then, yeah, at the end of the operation, it tells you what's happened. So that's all pretty simple. So that's the general life cycle of it. But of course, we need to know how to actually write Terraform. Otherwise, it's useless to us. So the anatomy of a HCL, so the HashiCorp configuration language, throwaway tidbit, it's just fun to say. HCL and TF can be the extension of your files. They're both the exact same. They just changed it a few years ago from being HCL to .tf, so they can reuse the language and use different extensions, differentiate things. So the other product which comes to mind is Packer. But in HCL, everything is a block. So what that looks like is we have only a small handful, but we have 5 or 6 different types of blocks. The most important one that you'll interact with is the resource block. So when you're telling Terraform what you want to do, you define a resource. A resource is a deployable asset. So your storage accounts, your resource groups, your NICs, everything like that. Something that gets deployed is a resource. When you're looking at a block, they all read the same. On the far left, they have the block type. So there's resource, variable, data. We'll cover those in a second. The bit that always catches people, which is another interesting thing, is inside of these quotes is where you start telling it what you're doing. There's actually 2 key pieces of information in here. So all the providers just follow this terminology. In theory, they could do others, but the safe way to read it is on the left, Azure RM is telling you that it's using the Azure RM provider. On the right is resource group, or how long that needs to be. That's the resource it's deploying. So this one is telling you that it's using the Azure provider to deploy a resource group. The last bit is the bit that we define, which can be whatever we want. It's a label. In this one, it's just RG. That's how we refer to it later in the configuration, so we can keep building things on top of it, which I'll show shortly. So if we put a storage account in this resource group, we tell it to use Azure RM resource group.rg, and that points it that way. So after resource, probably the next common one is variable. This is how you do the inputs into your project. So when you are doing your pipelines, you can pass things through, and we have different environments and such, but these read like what you expect. You have the block type being variable, and then you go straight to a label. So this is defined by us, so subscription ID, location, naming, and then they have a different parameters inside, the key one being the type, which can be strings or objects or lists, all those sort of common programming terminologies you've heard before, or arrays or whatnot. They're all built into there. As a bit of a side note, I've got this repo that I've built up on my website that I've got a link to at the end that has this repo in there, as well as documentation on all the different types. Otherwise, Terraform documentation is really good as well, but it's a lot to cover. So I've kind of glazed past this as quick as I can because I find that I can talk about this for hours. So after variables, we have locals, which these are probably the most unique type of block. These are where inside of the Terraform configuration, you do calculations or static values. You can have as many locals as you want scattered through your project. Usually carve them up pretty small so they're context driven by what they're next to. But inside you have the resource type, the block type, which is locals, and then you skip straight to labels once again. So this is the naming, and then it's whatever it is inside of there. These all get just mushed together. There's no dependency on these locals. You just keep calling locals, and use it as much as you need to. We have data blocks. So once again, data, and then the provider is Azure RM. The resource type that we're referring to is resource group, and then a label for that. What the data does is it's doing a read-only, basically a HTTP GET of the resource that you're interacting with. So this is something that's managed outside of Terraform. So in this, like a common one is if you're deploying a resource group by hand or somebody else is doing it for you and giving permissions on top, you can use the data to refer to it and then play on from there. And Terraform checks it, grabs all its values out and treats it like you deployed it in Terraform, so it has the same outputs from it, but it's just read only. We have modules, which these are a module. They're a pre-built set of code. Typically, you are using external modules. So in this example, we have the Azure naming module, which helps us build names as defined in CAF using the resource abbreviations and such. You can also use local modules, but I have a huge rant about modules later, so I'll save that for then. We have outputs, which are the output from the Terraform project that you're working in. So in the sake of a module, which is just more Terraform on the inside, the output is the output from that module up a layer to your Terraform project. When you're in the top layer of your Terraform project, something like this, that output's from the state file. So you can programmatically read it from other things like JavaScript or just any like jQuery or something like that. You can all read that from there. Outputs don't get used a lot, especially from the state file, but they're handy to know about. So those are all the different blocks that you'll run into. We'll go back to this one. So having a look here, files don't matter. So the reason I say that is we have all these different files here. So locals TF, main TF, networking TF and such. Terraform doesn't care about the edges of a file. When you run Terraform, you run it from a single directory, being the root directory of the project working here. It effectively just takes all the files, smashes them together, and then works out its dependency tree. So since it's declarative, if you're telling it resource group, storage account, virtual machine, Terraform knows they go inside the resource group, it'll do it in that order. You don't ever tell it what order it is unless you're explicitly telling it as a break glass sort of moment. But it's important to note that between these different files, they don't mean anything. We commonly use main TF and variables.tf so people know where they're looking for those sort of things, but otherwise it's up for us to manage. And I have a bit of guidance on that in a second as well. And this is the last big bit of when you're reading HCL, is how all these blocks actually jam together. So I have an example here. So we're going to play along with this resource or the storage account at the bottom here. So the first example we have is a resource calling another resource to inherit some values. So we can see here that we've got the resource group, a great RG is the label. What we're doing is this storage account needs to go into a resource group, which you call by name. So we're telling it here is the type for the block. So it's Azure RM resource group dot the label, which is a great RG, dot the value inside. So being name, so it'll inherit that value. When we're calling the next type, so we have variables themselves. So you'll notice for the resource group one, we don't have anything prepended to the front. It's just straight, you're assuming that you're calling a resource, but for all the other ones, you have something prepended at the front. So variable gets shortened to var. So it's var dot whatever your label is. So simply var dot name. Since this one is a string, it resolves out straight away. But if it was an object or something more complicated, you start going var dot name dot whatever it is inside, or whatever number it is. But that's all relatively intuitive once you start using blocks. It's all built the same. Sorry, got the highlight there. We have locals. So this is where things start getting a bit fishy. So we have locals up here with a location as the label, so the key for the value inside. You'll find here that it's not var or LCL or something like that. It's a local without an S. This catches everybody for ages the first time. It doesn't read right, just having the S stripped off. So keynote is when you're calling locals, remember that it's local dot whatever the key is that you're calling on the inside. Just to throw it for a spin and things get weirder again, when you have data, so this is those external types, you do data, highlight comes up, sorry. So data dot the block type, the block label, and the value on the inside. So var gets shortened, locals get shortened, data doesn't. The last one is module, which is very good because module doesn't get shortened either, even though it's the longest. So it's module dot whatever the type of module it is, the label for it, and then the value on the inside. That covers how you call these things. Effectively, when you're doing Terraform, this is it. This is how you build the dependencies, how you keep going on and on and on, reusing values rather than defining them 1,000 times. Alrighty, so I nearly got ahead of myself, but this one shows that dependencies are implied. So when we're doing the declarative nature of Terraform, you can imagine that in resource group here, the name is based off of the module, but for the virtual network, we can probably work out what the name is for the resource group. We're telling it exactly what we want it to be. If you just put the name in as a string, but don't have that depending on the resource group here, Terraform will just deploy them both. So what the really common thing to do, or definitely what you should be doing, is inheriting those values wherever you can. So this virtual network is using the Azure RM resource group, .rg.name, and the location, because we want it to be inside that resource group, and it may as well be the same location. Terraform now knows this depends on this, and part of the Terraform logic is it knows that they are deployment dependency, so it will deploy the resource group first, wait, then deploy the virtual network. Without that dependency defined in here, it'll just try to throw it out there and see what happens and error out. And the other one, which is a nice good rant, is debug does not debug. This is what people find a lot. They'll go to Terraform plan or apply and -debug and go, that tells me nothing, or spend 2 hours looking through the logs and going, this makes no sense at all. What Terraform debug does is for debugging Terraform for the Terraform developers. It won't actually give you any information about your configuration, anything inside the .tf files. It's a super easy trap. People think they're getting ahead of me and they're going to debug it and figure it out themselves, but it's just a rabbit hole you do not need to go down. When you are doing debugging on Terraform, the easiest thing to do is, well, first, don't write bugs. The second one would be keep your things small. This plays back into that CI/CD lifecycle of Terraform. If you're only changing 2 resources at a time, doing your plan and applies or you approve through the pipelines, something goes wrong, you know where you're looking. If you're doing 100, things get trickier. So rather than depending on a tool that doesn't exist, unfortunately, Terraform is quite poor in its debugging process, but it builds good practice in just keep your changes small, know why you're doing them, test them thoroughly, and you'll be fine.
Any type of IntelliSense lookup?
Yeah, sorry. That fell off my slides. That's a good call. So Terraform does have a VS Code extension that does all the IntelliSense stuff for the blocks and all the different values that are required on the inside. It's also really good at when you have the dependencies, like the resource group the resource group name value inside the storage account depends on the resource group. You can right click it, go to the dependency, and it'll take you straight to that in the file, or you can see where it gets referenced. It's really handy for that sort of tooling. But yeah, Terraform itself is just poor at troubleshooting. I believe it has a lot to do with the declarative nature, because it's not doing a script, it's just doing what it thinks. And that's, I don't know, they've decided it's too hard to give it a pause and let you tell what the values are and why I've made a mistake. Cool, so this is where we start going into more of the in-depth of Terraform, a bit of the tricks that I've learned along the journey. So we've referenced it a bit earlier. So files don't mean anything to Terraform, so they may as well mean something to us. And of course, when we're building Terraform, we want to build it in a way that it works everywhere. You don't want to have to build 3 sets of Terraform for dev, test, and prod. We can use it once and use variables to make it happen in those 3 different environments. And that gives you, once again, the good CI/CD, so you can actually elevate through your different environments. So what that might look like is something like this. So we get to have inside of our vars folder, which can be in a folder because Terraform doesn't traverse down. So we'll put folders where they're because they're good for us. You have as many different files like these as you want. The .tf vars and the .tf backend, they kind of do what they say on the tin. The vars can have your variables that you're passing into the project. The backend is telling Terraform where the state file is kept. So this will be in your Azure storage account or somewhere like that. A note with the vars is you can pass as many variables as you want to Terraform. So you can have global vars or have them somewhere else and do all sorts of clever stuff like that. But definitely the place to start is just 2 simple files and away you go. These get passed through to something like the variables.tf. So it's handy having that as common place to look. Because of course, when you start troubleshooting Terraform, you want to start following the dependency tree. You can have variables everywhere in your project, but if they're in the one place, you know where you're looking. And then when you start having different resources, you want to group them logically. Of course, this is always tricky because folders and files are a big bugbear of mine and they don't make sense when you start having things that span across 2 different places. but you try to keep them high level where you can. So something like virtual machines should have your virtual machines, but importantly, like their network interface cards or like their hard drives and all that sort of stuff bundled in there so you know where you're looking. Same as like networking is a good file as well because it has your virtual networks, your subnets, DNS zones, stuff like that. You try to keep these as high level as you can and use the VS Code extensions to dig around and go as you need to go. But definitely making more files is good. There's also a methodology of making a file for like each virtual machine or each network or each subnet, stuff like that. They don't scale as well in my mind because they get huge. You get a huge directory and you got to start digging through lots of things. I'd rather have one file that I can control F and start figuring out what's going on. And notably as well, when we're running Terraform in different environments in your pipeline, you can get it to log in with different accounts based on the details in the .tf vars and the .tf backend. So you can have a different identity for dev, test, and prod. So we commonly use the user assigned managed identities and use OIDC for sign in on GitHub pipelines. So that identity is running all the stuff that you need it to do. And it's all just kept in those files there and it's easy. Another easy one, which I've got on here because I'm burning for it as well, is variables should have descriptions, which is always easy. There's a description field. I've got a bad example here. Unfortunately, it's cut off, but you can do EOT file, like EOT, so you can do the less than EOT and do as long as a document as you want and close it off with the EOT and it prints out nicely, as well as just description fields in your variables. Be nice to yourself. If you're writing this Terraform, odds are it's probably not going to change for 6 months, hopefully, or until you need to expand or whatever. If you're not documenting it properly, you're always going to come back and it's never going to make sense no matter how good your Terraform is. If you put comments everywhere, and importantly, descriptions on your variables, you know what the project's doing. So things like description ID is pretty ambiguous, but once you start telling it, oh, yeah, this is where I'm deploying resources to, you're being kind to yourself, it makes sense in the future. The other part is, I've got in the video here, when you are running Terraform plan, if you're missing a variable, it'll ask you in the command line here. So if you keep nice convention, you can either substitute in as you go. Otherwise, it's just a good hint that something's gone wrong. This is the thing you didn't pass. Right time. All right, so the last little trick with the variables is you can, of course, have as many different variables as you want. I like to group them by objective, similar to the files. If you know where you've got one less place to look if you don't have it split out. So something like a variable and then naming, having things like your org code, app code, whatever, or networking, another cutoff example, having your address space and your subnets and such. You've got less places to figure out because you could, of course, just have variable for naming org code or just variable for org code, variable for application code, variable for environment code, but context is lost if you've got them split in lots of different ways. And on the left side here, this is an example of the TF vars file. You can see what it looks like. It's a very simple text. It's just the label and then whatever value on the right side of the equals. You can see that naming is pretty easy to understand. Networking, you've got your address space and subnets and a list. It all makes sense. It's easy to look at when you're coming back in 6 months and shit's hit the fan. You don't know what's going on. So I'll jump through this one quickly, but Terraform has looping logic to it. So of course you can deploy the same thing using effectively templates. I like to do object-based loops. So we're doing for each loops is what's going on here. We're doing a for every virtual machine. On the left-hand side, you define either a key and value, like a name for those, or an object. So we're just telling it that for every virtual machine defined in this list on the variable, we'll take the key. So the VM name suffix is named as the key, and then the value is the whole block, and we call it in here. So that bit's complicated. The bit that I wanted to show, which catches everybody when they're first learning Terraform, is it's really weird how you call out values in that loop. When you're doing a loop, you're no longer just calling a something dot or whatever. You do each. So each is the shorthand for saying this one in the loop, the value. So this can either be key or value. If it's key, it'll be this value that's represented on the left here. If it's value, it'll be the one on the right, so this .o. And then it's dot whatever, sorry, I've used the term too many times. It'll be dot whatever label it is on the inside. So if you're going each value hostname, you're looking at this one for each member in the list. The other one is don't use counts for your loops. So the alternate way is you're doing a count, which sounds great. I want to deploy 10 VMs. I'll just tell it to do 10. When you do that, you're losing the power to edit the ones in the middle. 5, 6, and 7. Now you can't edit the VMs and like the CPUs or whatnot. But more importantly, what happens if you want to delete 5? Cool, I can just delete it from the Terraform config or change the number. Terraform's really dumb about it. If I've deleted 5, 6 becomes 5, 7 becomes 6, 8 becomes 7. They've all got the wrong name, they all get deleted. You cascade and everything's getting like cycled out. If you just did object-based loops at the start and have named values, you can at least pick on the one you want to delete. And you can programmatically generate these names and such as well, but counts just lead to traps in Terraform. What we do use counts for quite heavily is as a feature toggle. So in this example here, if the OS type is Windows on the virtual machine we're trying to create, we'll create a Windows virtual machine resource. In Terraform, there's 2 different types for Windows and Linux. This is just a simple yes or no for deploying something like that. That's the depth of what we use them for, and they're very powerful for that. Basically, we can't count higher than 1, so we just get stuck and we just stay there. Last little bits that I'll quickly jump through so then we can get to questions. So common mistakes to avoid. Avoid making modules. So we've shown them a bit before as well. Modules can be either something that's referenced as an external module or something that's kept locally inside of your file system. The external ones, awesome. I use them all the time, like the Azure naming module and such. The ones built into your project, I've struggled to find proper use cases for them. They sound clever, like you're moduling something like a virtual machine that has a network interface card, hard drives, NICs, the virtual machine asset itself, and you just loop over that module and do what you need to do. When you're defining a module, you have to define variables and outputs and everything inside, just like normal Terraform. You'd start doubling up on your workload quite a lot troubleshooting those modules. Once again, Terraform's troubleshooting kind of sucks. So if we don't use modules and we just use for each loops instead, you'll find it's a lot easier to troubleshoot. Even in the Terraform documentation, they tell you basically don't use modules too much. Their shorthanded guidance on what modules are for, they say if the only name you can think of for your module is the resource that you're deploying, probably too simple. It needs to be something much more complex than that, otherwise you're just shooting yourself in the foot, adding complication where it doesn't need to be. This is a really big one, as another one that's a key takeaway. If you take away anything from this when you start playing with Terraform, Terraform records everything in the state file. If Terraform has touched it, it remembers. So even if you use a data block, if you've just passed it in, it records everything in the state file because it likes to keep track of what's changed. So if you use a data block on a key vault secret and even don't use it in the rest of the config, it records everything to do with that secret, including the secret value. The state file currently might change in the future, but currently the state file is not encrypted. It is plain text. So in this example here, my admin password is, no, I don't know how I got hacked. It's just purely in the state file, easy for anybody to read. The state file is something that is privileged information. You keep it in Azure. I keep it in a storage account. That's got the storage access keys disabled. It's purely using RBAC. It's firewalled to the machines that we need to use, or more, or even better, nobody has access to it beyond the managed identity that runs the CI/CD pipelines. You want to lock this state file as far away as you can, because it can just slowly grab onto more and more information, and it's a huge honeypot for somebody to infiltrate your company or application. And this is the blueprint on everything. No good, scary, bad. Do everything you can to protect it. Just remember that. I'll loop back to it, which is why we use remote states like storage accounts. If you use a local one, it goes into your local file system. If it ends up in Git, it's stuck in Git forever until you really try to yank it out. You could have the state file on a USB drive and pass it between your friends, but it all gets dodgy. Remote state from day zero in a storage account if you're playing in Azure is awesome. It's simple. It's really not hard to set up, and it'll just save you so much stress. The last little one is AI tools just don't get it. So Terraform is a domain-specific language, as we mentioned, so it has no roots in anything else. It's also gone through major change in the last 3 years or so. Not so much that it's hard for us to write it, but AI tools don't keep up with that. They're trained on old information. They don't understand the context switch. They like to ruin your day when you get it to make code for you. I'd love to say otherwise. I'd love to be able to go up to Copilot and say, deploy me 2 VMs, but it just never works. And in fact, when I have people, I'm teaching Terraform, they go off to the side, start using Copilot or ChatGPT and think they're being clever and use that. I spend all my time troubleshooting their stuff because it just doesn't work. I do use Copilot very lightly as a very smart copy paste, but even then it causes issues. So I wouldn't use it as a brace. I would just learn it the right way. It is simple. AI tools make it so much harder than it needs to be. So apologies for speeding up too much there at the end, but that's it. So as I mentioned, the repo is up on my silly little website. It's just got everything you've got there, as well as a big list of my tips and tricks in a very just brain dump way, and a list of all those types and such in there. Otherwise, it's got my contact information, of course. I like talking about this stuff. I could do another 2 hours. But yeah, thanks for listening.
So, do we have any questions? I know there was some questions over here
Yes.
before, yeah?
But answer to one of the other one is that is this Drop an open source product? I didn't want license it on there.
That's a loaded question. So Terraform used to be open source, but it has recently changed. It is now under the business source license, I believe. It's effectively, a bad way of terminologizing it is source available code. You can read it, but you can't fork Terraform and then build your own. You also can't bake into your products and say, this is not Terraform. There's an asterisk on there. Your mileage may vary. You can definitely use it in an enterprise sense to deploy everything you need to do. If I'm being blunt about it, I believe that change has a lot to do with Spacelift is the name of the product that was using it. It was effectively just taking Terraform, rebuilding the Terraform cloud platform, and just saying it is Spacelift. They've done what they can to rule that out. Otherwise, the next question that might come up is HashiCorp was recently purchased by IBM. So they're now part of the IBM family, whatever that means, we don't know yet. That may have been a power play into that. But effectively, yeah, Terraform isn't open source. There is an open source alternative that was forked prior to the license change called OpenTofu, which is OpenTF. Right now, they're at feature parity. What that might be in the future, I don't know. But right now, you could take the code from one, swap it to the other with minimum to no changes. My advice, I like open source. I want it to thrive and all that good stuff. Back to slide 5, Terraform is the brand name. It's really, really big. I love for OpenTF to be a legitimate competitor, and I want it to be so. But right now, I'll look more at Terraform still. We have no reason to jump ship. It still works for everything we want to do.
The only limitation is if you want to fork it, change it, ship it, resell it, you can't do any of that, but it's free.
No, so
free for commercial use kind of thing, right?
Yeah. Nothing's changed in that regards. It's only in the 1% that is like not stuff I've had to interact with at all. Like we've contacted HashiCorp and Terraform when that license change happened, because of course we sell Terraform products, right? Like we do projects for people, stuff like that, using Terraform or using it to deploy stuff for customers. That use case doesn't change. The wording is a little bit loose on what the business use and what it looks like. I don't remember the exact wording in my head, but we haven't found any concerns for it, and we're writing thousands of lines of Terraform every day. So I don't have any reason to go, oh no, this is bad. And on the front of IBM buyout, I tend to want to look at it in a positive light. They're a big company. They've got a lot of power behind them. It could mean good things for the ecosystem. So I don't want to spread fear in saying, oh no, sky's falling. Sky could be rising.
Ask you, maybe give us a little bit of color on this relative to Ansible, and Ansible obviously uses YAML.
Yep.
Looking at this, obviously it's not YAML, but it's
It's similar.
YAML-ish.
Yes. So YAML is very, very text based. It's almost like you're doing a bullet journal on what you're trying to do. Ansible itself is a really cool tool. I've used it extensively. It can do what Terraform is doing in resource deployment and such, but it's not designed for that. I found that Ansible is a lot better at the OS layer, customizing whatever Linux or even Windows machine you're doing and such. Application layer stuff, all that, but its strength isn't the infrastructure side. I'd still use Terraform for that side and then Ansible on top, which is where IBM owning both could be a powerful thing. I imagine that's part of the strategy, is they'll have a full solution on end-to-end deployment with best-in-class tools at every step in the juncture.
The state file, how do you manage the cross-team company best practice state files? How many, do you use your own state file?
No, so state file is definitely a shared entity. Everybody that is interacting with Terraform to do applies, particularly, has to have access to the state file. It's as complicated as I want it to be. How about that? I would always suggest that you start with nobody has access to the state file except the CI/CD pipeline. So the managed identity is running as that, and work backwards from there. You can give privileged people access to the state file so they can run plans, but really never applies from their local machine. So they can validate their configuration and check changes before they push it up to the pipeline. But I would work backwards from the most secure possible. And in regards to those state files, you'd have one per environment is the way I typically do it. You can do whatever you want, but I have one for dev, one for test, one for prod. Keeps it simple. You can, once again, Terraform's flexible. You could, in theory, have one state file that has dev, test, and prod all inside of it in one big configuration. But it doesn't play into my mantra of keeping things simple and small. I prefer to stack it out by those, especially in regards to prod. Nobody wants to break prod. Dev and tests, a little less important. So you can have those all in one storage account as different blobs, for instance. But I tend to have one storage account and one blob. So one for dev, one for test, one for prod, because then you've got different layers of RBAC on top. So you can be a little bit more forgiving with dev and give people access to that, but prod is prod, nobody touches that.
That just means that everything gets deployed through Terraform. No one is doing stuff manually, and if they do you import it?
Yeah, so there is tooling like the data block to import stuff as a read-only asset, or you can do import in literal sense where you have a resource block and you import it over the top and Terraform pretends that it owned it the whole time. This is where Terraform gets a little bit more how important it is to your business, more as a business use case than it is as a technology. It can do whatever you want. You can use Terraform once to deploy all your infrastructure, pretend that you don't have a state file and just click ops it from there. Or you can do that, change stuff in the portal and then import it. That's always going to be cumbersome. My guidance would be for dev and tests, I care less. For prod should be Terraform. I find it hard to justify a workflow where stuff going into prod isn't getting approved. And if you're doing that through CI/CD, through your pipelines, that's an excellent place for people to get the final say of what's actually going into prod, rather than somebody getting PIM, like privileged identity or whatever, to elevate to be able to modify prod. And who knows what they really did. They changed the storage count, sure, but what else did they do? You have to check your logs, whatever. Let's stop it at the front. If everything goes through Terraform, we have the GitHub or whatever CI/CD platform using logs of exactly what happened, who approved it, why it happened.
A question on use cases.
Yes.
How far up the stack use this? Is it mainly infrastructure, VM? Do you go into application?
So it does this is where it does play nicely with Ansible. That's the funny line it gets drawn. Terraform's really good at the infrastructure side. We do use it for deploying containers from a registry because that's something known and passed along. You can use it for controlling, let's say, Windows and deploying applications and stuff on there. It's junk. Don't do that because OS layers aren't declarative. And if in that use case, there's better tools like Ansible that are more akin to doing that. But yeah, we use it for everything up to the finite app layer, like everything up to containers, and then otherwise backwards from there. So networks, storage accounts, subscriptions, yeah.
Is that where you draw a line, declarative resources versus non-declarative resources?
Yeah. So when you start doing things like installing applications and stuff, they're a little bit more imperative. They are script-based. You can actually even just run a script inside Terraform, but it's more of a hack job than it is its intention. Terraform is definitely an infrastructure tool. Sometimes there's a use case for just going that a little bit further, so you're not doing two tools. But I would start with it's just infrastructure layer. It's also potentially a good handoff to other teams like your app team. If the infrastructure side is doing the full deploy, they're getting the app service plan or whatever ready, and then you just tell the developers put your app there. There's usually a line that can be found.
What about resources that are idempotent versus non? You talk about declarative, doesn't mean they're idempotent. The fact is, obviously in Azure, you can write over top of a resource all the time, and it won't change unless there's a change in that declaration.
Yep.
What about resources on other platforms that aren't that way?
So Terraform, it does keep track of all those things, and in
So it
particular,
keeps track of the state of the existing deployments as much as Azure does.
yeah. So what it will do is the state file is only as good as the last time you ran it. In a crude example, something like a blob, Terraform will notify you something's changed outside of Terraform, and it keeps effectively a configuration, not something that's explicitly exposed to you, but it will say, this has changed, I'll update the state file, I'll allow it. Unless you're
That's the import you're talking about.
no, so import is a literal command, Terraform import, to bring the whole resource in.
You can take an Azure resource and import it into a state file.
Yep, but when you're doing that, it needs to be in your code, because you're effectively just adopting it to being inside your Terraform. Like if something in your blob changes, the jury's out on whether Terraform will want to change it or not. There is also a lifecycle parameter, it's called, where you can say ignore changes. So you can literally say, if the tags change on the storage account, I don't care, just leave them. It's just part of practice of using the system. You'll find these things, and once again, it plays into the do many small changes rather than one big change. If you're doing these things over time, you'll learn these tricks, and you can do the ignore changes where you need to, or no, maybe the blob doesn't need to be in Terraform. The storage account, sure, but the blob, I don't really care. I'm sort of just providing that. I don't need to maintain every layer. You find what lines need to be drawn that makes sense for your team and lifecycle.
So you're talking about Ansible before being for things that are less or not declarative, but everything in Azure, almost everything is declarative.
Yes.
So it works pretty well for applications if it's in that declarative state.
Yep.
Or app
Yeah, so
services or other types of things.
Yeah, so the main use case I've used for Ansible was in a prior life on-prem for maintaining like Linux and Windows machines.
Right.
Ansible doesn't make it into my tool set for everything I do in Azure, in deploying infrastructure and deploying apps and stuff. I find that Terraform does end-to-end everything I need it to do. It's not a compromise. It's just really good.
Sort of like you use Terraform to say I've created this VM, but then you use Ansible to go, okay, this VM needs this.
Yes, correct. Yeah. So VMs is where, in particular, where it gets tricky.
Configuration.
Yeah. So there's tools that are better suited for that in my experience. So even like PowerShell DSC, although I think it's been abandoned or never took off, or somewhere in that middle ground, or Ansible or SCOM, or all those sort of things that like Windows. That's that ecosystem where like Azure infrastructure above is where we're doing.
In the app space, I guess like Terraform can deploy like an app service could deploy,
Yeah, 100%.
your function apps and stuff like that, but then you still deploy your code through your general, like your
Yeah, there's that once
so
again
you
that
have the separation. Yeah.
So we've done definitely like your builds as part of the pipeline, and then Terraform Terraform just takes that latest build and pushes it up. Like it depends on where it fits into that life cycle, especially if you've got two different teams that one manages infrastructure, one manages the app. You probably don't necessarily want the app people inside your Terraform pipeline because then their eyes go blurry and they start freaking out because they have to look at all the Terraform. It might be a separation of duties. Otherwise, it's like they control their container registry and they tell you use this tag and you change that in the Terraform, or tell Terraform to always use the latest or something like that and push it through. So it just depends on where that separation of duties and where it logically makes sense for all the other complexities in the deployment.
Does it actually use the Azure like a REST API internally, or
Yes.
Or
So yes. So
internally, or, yeah.
so it's gone through a bit of a life cycle. So there's two providers, which is those plugins. There's Azure RM and AZ API. So Azure RM is their very friendly, basically almost front end for Terraform, where you saw things like, maybe I can even backspace to it a little bit. So I'm going to reveal the magic on how all the videos worked. So here we have, this is Azure RM. So you got a nice field like name, resource group name, location, locations for giving. Like if you tell it Australia East with no space or with a space or with capitals or whatever, the Azure RM provider is being very nice and will figure it out for you. In the background, it used to use ARM templates, I believe, but it has since changed to being the REST API. So the actual Azure Resource Manager, the API side of that, is a lot more native to that. AZ API is just REST. It's really, really powerful. Actually, I'm tending to lean more towards that way because the ARM Azure RM, it's a little bit friendly. Like you don't necessarily know, like there's probably no good examples on the screen here. But like what's admin password actually mean in the background? What API endpoint does that reference? What is that value in the REST API? When using Azure API, it's brutally that. It has some niceties on top, but it is also really clever that it takes those APIs and makes them declarative. So when you're using AZ API, if you delete something, it knows how to delete it. If you change something, it knows how to do it. It's very cool. But I would suggest using Azure RM first, just because it is friendly and nice, but it doesn't get the tooling as quick as what the portal deploys. Sometimes you get a feature in the portal that hasn't made its way to Azure RM because that has to go through a new release and get pushed out. The AZ API is always the latest up to date because it is just brutally REST API. So if you're using a cutting edge like pre-release feature, probably isn't in Azure RM, but it definitely is in AZ API.
But in your files, you can still mix and match it.
100%.
You could still, create a VM using Azure RM, but maybe there's a cool new thing that you want to deploy.
Yep.
Go through the other.
Yep. So we use that quite a lot. You can mix and match, and even in the same Terraform code, you could call out to Google or AWS or whatever. It's just a matter of keep plugging in those providers and keep doing what you need to do. So Terraform can help deploy, let's say, an easy example is you have VMware on-prem and using Azure SQL, but you're using virtual machines on-prem. One Terraform code logs into both providers as the cloud platforms and does what it needs to do. Yes.
Best practice adopting Terraform in virtual environments. You say looking at the Azure, are you thinking we create a new subscription and build it up from scratch, or do you kind of, which will be tricky to start building in the current environment?
It overall depends on the complexity. I would always say that starting small. Once again, you don't have to boil the ocean. You can just bring in the resource group and the storage cap and progress from there. The import cycle for Terraform is cumbersome. It's just by virtue of you're importing something, you rework. It's always going to be a little bit of pain. But so in that respect, I would say that doing a fresh deployment with it is maybe the nicest way because there is tools out there. I failed to remember their names because I don't use them, but they're like the Terraform Azure import or something keywordy like that you log it into your Azure, it reads it and makes Terraform files for you. That's a good first step, but it also leads to compromise because it's not doing loops and conditionals and stuff like that. It's just brutally taking your stuff and there it is. I'd prefer to, if I am going to be importing stuff that's priorly existed. Either decide, do I want it to be data blocks, so just read only, and we'll just move on, and that stuff stays how it is, or we use import blocks to start managing it in Terraform. It just depends on if you're just wanting to use it in your Terraform configurations or you want it to be your Terraform configuration. It's where that line gets drawn. But yeah, that's one of the tricky parts of it, and that's honestly effectively what I do all day, right? Is working with businesses and companies to help move their app from A to B and doing stuff along that life cycle. So there's plenty to do there. Was there
Any other questions online? So
No, excellent.
Cool.
All right. Thank you very much, Ryan.